Imagine standing in a blinding snowstorm, 40 degrees below zero. In a prehistoric winter, exposing yourself to these conditions is a guaranteed death sentence. There are no space heaters, no power grids to plug into, and no synthetic cold weather fabrics to protect your skin. Yet, just a few feet away, a family sits in a softly glowing, deeply warm room. They aren't shivering, they're comfortable. So how did early humans carve out a pocket of warmth in this deeply freezing environment without a single piece of modern technology? They survived by decoupling their living space from the surface climate, using the density of the Earth to create a stable, protected thermal zone. The first step required brutal physical labor. Hunters would identify a patch of solid ground and manually dig a massive pit deep into the earth. To break through the frozen topsoil, they relied on thick antler bones, using the curved, durable points as primitive but highly effective picks. This excavation allowed them to harness a concept called thermal mass. Heavy, dense materials like solid earth absorb and store heat slowly, while acting as an impenetrable physical barrier to freezing surface winds. Looking at this vertical temperature gradient, you can see the thermodynamic benefit of digging down. While the surface remains violently cold, the ambient temperature at the bottom of the pit stabilizes, entirely divorced from the storms above. This manual excavation functioned as a static defense, using the mass of the earth to blunt the impact of the freezing surface air. But an open pit has a fatal flaw. Heat naturally rises. Any warmth generated at the bottom of the shelter would immediately escape out the top. Closing off that pit required a heavy structural foundation, capable of supporting massive amounts of insulating materials. Builders constructed a complex, interlocking framework out of massive mammoth bones and tusks. Over this sturdy frame, they added sequential layers of material. First, animal hides blocked the wind. Next came thick layers of grass. This grass created dead airspace, small trapped pockets of air that restrict heat transfer, which is a core principle of insulation. The final layer seems counterintuitive. Allowing a thick blanket of freezing snow to accumulate on top of the grass completed the heat trap. It reflected the rising thermal energy back down into the living space. Inside this sealed environment, internal heat sources went to work. A carefully vented central fire, the heat radiating from cooking meat, and the combined body heat of families sleeping closely together provided constant energy. With these layers in place, the structure functioned as a closed system, retaining generated warmth and keeping the family safe from the lethal conditions above. By continuously maintaining the fire and patching the roof, these shelters held strong against the deepest winter freezes until the spring thaw finally arrived. Millennia have passed, but the brutal, universal force of winter cold still threatens us today with the exact same lethal intensity. Modern homes survive using the exact same physical principles we see in these ancient pits. We layer materials inside attics and walls to create pockets of dead air that trap heat. We often credit our survival to modern mechanics and digital thermostats, but true comfort relies on the same application of raw physics and smart design used by our ancestors. We survive extreme climates through an ancient creative ability, the capacity to turn the Earth itself into a life-saving thermal envelope.